All right, so this is part 3 of the law of signs problems. I'm going to do problem 7, 8, and 9. Problem 7 is pretty straightforward. I think we've done one earlier like this, so let's run through the annotation. All right, top of a building. Observer watches a boat sailing directly toward the building. Observer is 100 feet above sea level. Angle of depression, it changes from 25 to 40. How far did the boat travel? Okay, so we have a building, and here's the sea. All right, so somewhere out here is a boat. That close enough. So there's my boat. Let's see, the building, the observer is 100 feet above sea level, so there's 100. All right, so the observer is looking down and spots the boat. The original angle of depression is 25 degrees. Now remember, angle of depression is outside the triangle, so that would be up here, 25 degrees. It actually is a little bit easier to remember that angle of depression is going to be the exact same thing as angle of elevation. So this angle right here is 25 degrees. Okay, so that would be the same if somebody on the boat was looking up at the top of the building. That would be the same idea there. All right, the boat is going to travel towards the building. All right, and then that angle is going to change. So let's see here. So then this angle would be the new angle of depression, and I'm pointing to this angle way up here in the corner. This would now be 40 degrees, all right, which also would correspond to somebody on the boat looking up at an angle of 40 degrees down here. So I'm going to go ahead and mark this angle as 40 degrees. The building is going to be perpendicular to the sea or the ground, whichever case might be here. And how far did the boat travel? So we're looking for X right there. All right, I'm going to go ahead and zoom in, fill in some angles, and see what we can figure out. So 40, 50 degrees here. This is going to be 140 degrees right there. And let's see, I have a calculator sitting next to me. Let's not make any dopey mistakes. So this angle is going to be 15 degrees. All right. So in this case, I know enough to figure out my right triangle. So I'm going to find the hypotenuse. And I'm going to use the hypotenuse then to find X using law of sines in the big obtuse angle, or the big obtuse triangle. To find H, I'm going to go ahead and use my 40-degree angle. So sine of 40 degrees is equal to opposite over hypotenuse. So H is going to equal 100 over sine 40. Into my calculator that goes. So I have a hypotenuse of 155.57 and some more stuff after that. Now that I know H, I'm going to use, let's see, this hypotenuse, which is now just one of the sides of the triangle, is opposite the 25-degree angle. And then, let's see, X down here is opposite that 15-degree angle. So that's the law of sines I'm going to set up. So sine of 15 over X is equal to sine of 25 over H. Let's see, X is going to equal H sine 15 over sine 25. So into my calculator, I already have H. So I'm going to take that and multiply it times the sine of 15 and then divide it by the sine of 25. So X is equal to 95.28. I didn't round properly, so 28 feet. All right, double check. Yep, no rounding direction, so that's all it's going to be for that problem. All right, let's go to problem number 8 here. Angle of elevation to the top of a tower is, now this notation you may never have seen before. It's 42 degrees, 20 minutes. And I'm going to explain what that is in a moment. Let me go ahead and find the rest of the information in this problem. Angle of elevation 50 feet further away is 37 degrees. Find the height of the tower to the nearest minute. Okay, so here's the deal. You have something called degrees, minutes, seconds. So an angle is measured in degrees. That's one of the measurement tools. So we know what a 90-degree angle looks like. All right, so basic 90-degree angle, that's 90 degrees. I'm going to zoom in on just the picture temporarily. So the idea is that there is a little itty-bitty wedge here. All right, and I don't draw it too well, but that's okay. We are going to say that this is a 1-degree angle. Now, 1 degrees does not sound like very much when you think about the fact that this is a 90 degree. There would be 90 of those in this angle, right? That seems pretty accurate. Until you think about the fact that as we go further and further away, this is going to get further and further apart. And when you're dealing with things like, oh, I don't know, trains and automobiles, and you're dealing with long range distances around the Earth, 1 degree can make a really big difference. So what ends up happening is every degree, all right, so this little 1-degree angle is further split up into 60 minutes. So imagine basically slicing this up into 60 pieces, and each one of those pieces would be considered 1 minute. And then every minute can be sliced up into 60 more pieces to create seconds. So degrees, minutes, seconds. For the problems that we're going to deal with, we are only going to be working with degrees and minutes. So I'm going to go ahead and kill my little picture here. So how do I get degrees and minutes into a calculator that only understands degrees? Well, what you're going to do is you are going to take your degrees and you are going to add your minutes divided by 60. All right. So remember, every degree is broken up into 60 minutes. So if we just take those minutes divided by 60, it would convert them to degrees, and you'll get a decimal value to work with. All right. So I got 42.3 repeating, which I'm going to try and keep as accurate as I can. So this is going to sound weird, but I'm actually going to use 127 over 3. All right. You know what? Actually, better yet, let's make it a little easier to work with because we're already going to have enough accuracy. Let's go 42.33 degrees. We'll keep it to 2 decimal places and work with that. All right. So now that we know what degrees we're going to be working with, let's go ahead and apply it to the picture that we've been doing. So we have a tower, angle of elevation. Let's make our little right triangle here. So somebody standing out here is 42.33 degrees away from the tower, or that's the angle of elevation, okay? If we then take this person and they back up 50 feet further from the tower, now the angle of elevation has changed to 37 degrees. So this angle is 37 degrees. Find the height of the tower to the nearest minute. That makes absolutely no sense because you don't measure height in minutes. So we're going to go find the height of the tower to the nearest tenth. All right, I will make sure on any test questions that's adjusted, any formative questions. Yeah, you're not measured in terms of, inches and minutes. It doesn't make any sense. Degrees are measured, or angles are measured in degree and minutes. All right, let's use some of this information to get the rest of the angles. So this 42.33 is supplementary to the angle next to it. So 137.67 degrees. I can use these two angles to find this third one. So I'm putting that into my calculator as I sit here. This is 5.33 now. So 5.33 degrees. And now I can use the 42.33, the 90. So that's going to give me 47.67 up here. So 47.67 degrees. And let's see. I'm going to do what I've been doing. We're going to find the hypotenuse here. So let's see. This H here is opposite 37 degrees. And then 50 feet down here is opposite to this 5.33 degrees. So law of sines, here I come. So sine of 37 over h is equal to sine of 5.33 over x. Nope, 50. I lied. I actually just got confused. I had to look at the wrong thing there. Okay, so let me reset that and make sure I got it right. So h is going to equal 50 sine 37 over sine 5.33. Into my calculator, this all goes. Let's see, sine of 5.33. All right, so I have a hypotenuse of, or an h value of 32.39, some more stuff. Now that I know the h value here, I can use the right triangle. I'm going to use the 42.33 with x and h. So let's set that up. Sine of 42.33 is equal to opposite over hypotenuse. So that's going to be h times sine of 42.33. Now, always remember, I'm using my calculator. So h is already in there. So I'm going to just multiply it times sine of 42.33. And I said to the nearest, I had to fix that, but to the nearest tenth. So just one decimal place, please, and thank you. So 21.8, and I believe this is in feet. It is. So our tower is 21.8 feet tall based on the information given. All right. So that's how you work with degrees and minutes. And I believe problem number 9 has more of those in there so we can get some more practice with it. All right. A hot air balloon is sighted simultaneously from two towns that are 5 miles apart. The angle of elevation from one of these towns is 40 degrees 27 minutes, and from the other is 58:41. So what I'm going to do first is zoom in on those degrees and minutes, and I am going to convert both of these into a decimal that I can work with. So 40 degrees plus 27 over 60. Let's see what fun I get when I do that division. So 40.45, and there's no decimal. This isn't rounded at all. Okay, so that's actually really nice to work with. And we've got 58 plus 41 over 60. Let's see what that turns into. I'm going to guess that one might not be, nope, not quite as nice. Let's see, so that's going to be 58.6, and I'm going to round it off to just 68. There was a repeating 3 after the 8. Okay, so let's go ahead and draw the pretty little picture. So somewhere up here is a, I don't draw these well, hot air balloon, close enough. And we have two towns. So let's see, here's a town and here's a town that are 5 miles apart. The angle of elevation from one town to the hot air balloon is 40.45 degrees. Let me fix that 0 there. There we go. And the other town is 58.68 degrees. Find the altitude of the balloon. So we want to know this height right there, all right, that altitude. So this is actually very much like, I think it was one of the first or second problems that we did on this page. What you're going to do is use these two angles to find this angle. And then once we know this angle, we can use law of sines to find one of these two unknown sides. Once we know the unknown side, once we found that side, we can use the right triangle to find h. So for no particular reason, I'm going to go ahead and find this edge right here. So I'm going to call this, let's see, I'm finding h. Let me actually change this up just a little bit. I'm going to go ahead and call this x still, because that way I know that's what I'm solving for eventually as the final answer. And I will call this edge h for hypotenuse. You can call it whatever you want. Smiley face works. So let's find this angle first. So 180 minus 58.68 minus 40.45. So this pink angle up at the top is 80.87 degrees. Now that I can use, let's see, this angle with its opposite side and this angle with its opposite side, I can set up a law of sines. So sine of 80.87 over 5 is equal to the sine of 58.68 over h. So 5, wow, let's try and write that 5 the right way. 5 sine 58.68 over sine of 80.87. All right, into my calculator this is going. As soon as I put all the decimals in the right place. All right, so I'm getting an h value of 4.32 and some more decimals after that. So now I can focus on just this right triangle on the right side. So I know this angle is 40.45. The opposite is what I'm looking for, this height, and the hypotenuse is now what I know. So setting up a sine problem, not law of sines, but just sine. So sine of 40.45 is equal to x over h. So h sine of 40.45. Into the calculator it goes. Find the altitude of the balloon. It does not give me any rounding instructions, or I didn't give you any rounding instructions, so to 2 decimal places, please. So 2.81, and the units in this case are in miles. All right, so that is a little bit of practice with using law of sines, but also it involves the degrees, minutes, seconds. And for our case, we're just going to be using degrees and minutes. So please make sure you know how to convert from minutes to degrees. Remember, it's just divide by 60. And then let me know if you have any questions or concerns about these problems, or if you think I've done something wrong, please politely tell me and I will fix it. All right, I will put up the answers for the advanced SOHCAHTOA problems 1 and 2 into the note key, but I'm not going to make a video for it unless somebody asks for it. So if you do have any questions or concerns, or you want to see a video for those, let me know how I can help.